Hey guys, this is Miss Bufford, and in this video we're going to talk about hydrates. So your learning goals are to be able to explain what a hydrate is in your own words, to calculate the number of moles of water in a hydrate, and to correctly name and write the formula for a hydrate. So what is a hydrate? This is a crystalline substance that forms and includes water molecules in the organization of its crystal lattice structure. So hydrates can absorb water from their surroundings and incorporate those water molecules, include them in the chemical structure or their crystalline structure. So we've talked a little bit before about the fact that ionic substances form crystals. A hydrate does not have to be an ionic substance, but a lot of ionic substances have hydrate forms. Remember that an ionic substance comes together when positive and negative charges alternate, right? And so sometimes we get water molecules filling the spaces in between these positive and negative charges. All right, and some ionic substances are really good at attracting water molecules. So if we leave the lid open, if we were in the lab, then sometimes you would notice if we leave the lid open, occasionally some product or reactant that we have will absorb water and become wet just by absorbing that water from the air. So that's all a hydrate is just a crystalline substance that can absorb water and incorporate that water into its crystalline structure. All right, so the next thing we need to know about is how to write the formula for a hydrate and how to name a hydrate. So the formula for a hydrate is written using the chemical formula. So we write out the chemical formula, and then we add a dot and H2O to the end. If there's more than 1 mole of water present in the hydrate, then we use a coefficient before that water molecule to describe the number of water molecules that are present for every unit of the compound. So basically what the formula for a hydrate is describing is the ratio of the units of the compound to the molecules of water that are present, absorbed in that compound. So we take a look. The hydrate formed from aluminum bromide with 6 water molecules is written as this first. We write the aluminum bromide formula, and then we add the little dot, and then we add the 6 water molecules right there. All right. So when we're naming a hydrate, we have to use prefixes to describe the amount of water. So we've used prefixes before when we named covalent substances. But here, since we're describing the moles of water, we would just use the same prefixes to describe how many moles or how many water molecules there are. All right, so for example, the same compound would have the name aluminum bromide hexahydrate, right? So we just use the word hydrate, we add the prefix that indicates how many water molecules there are, and then we just attach that to the end of the compound's name. All right, the last thing that we need to know is that the word anhydrate is the compound without water. So when we describe something as a hydrate, that means it has water included into its structure. But if we were to heat a hydrate up, we could get all the water to evaporate out of those crystals, and what we're left with is the dry substance or the anhydrate. All right, so this anhydrate is a dry compound, meaning without water. Okay, I forgot my D there. All right, so now we're going to do some examples so I can show you guys how to calculate how many moles of water there are in a hydrate. There are 2 different examples I have. The first one is how to calculate these if you're given the information on percent composition. So if it tells you what percentage of the compound is water, then you can use those percentages just like we did before to calculate the ratio of the compound to the water molecules. All right, and so again, I've listed out the steps here if you need to refer back to them, but I'm just going to go ahead and go through this example first before we talk about the steps. All right, so this first example says a hydrate of copper 2 hexafluorosilicate is found to be 65.5% copper 2 hexafluorosilicate and 34.5% water. What is the formula for this hydrate? So what I want to do is I'm just going to write down the information I have. I have copper 2 hexafluorosilicate. That's this compound right here. And I gave you both the name and the formula in this problem. If this is not something I would expect you to be able to name on your own, so in that case, I would give you both the formula and the name so you could include that in your answer. All right, and we know that this is 65.5% of our compound, and we know that water, H2O, is 34.5% of our compound. And so the first thing that we want to do is just like before when we started with percentages, we want to pretend that we have 100 grams so that we can easily convert these percentages into a mass that we can use. What I will say is that we are doing the same thing as far as determining the ratio here. So our goal is to convert these eventually from a percentage all the way to an amount of moles so that then we can compare the particles of, or the formula units of copper 2 hexafluorosilicate to molecules of water. All right, so let's go ahead. We're going to pretend we have a 100-gram sample. Okay, and if we have a 100-gram sample, and that means that 65.5% of that is going to be 65.5 grams. And the same here for water, so 34.5 grams of H2O. And this is, so when you're given the percentage data like this, it's really easy to pick out your anhydrate. Remember, and the anhydrate is the compound that does not have water in it. And so this right here, this part is considered our anhydrate because we've separated it. We're just considering it all by itself. So if this was a compound that we had dried out, then that would be our anhydrate. And then water is the hydrate part, or the hydrate, yeah. All right, so now that we're in grams, we have to convert these to moles. And in order to convert these to moles, I have to have the molar mass for both of these compounds. I have to have the molar mass for copper 2 hexafluorosilicate, and I also have to have the molar mass for water. So let's go ahead and do those calculations really quick. So I'm going to do, I have copper, silicone, and fluorine. And there's 1 copper, 1 silicone, and 6 fluorines. And so I need those molar masses from the periodic table. So I'm going to pull up my periodic table. I'm going to find copper. It's right here. So let's see. We're going to use 63.55 for copper. That's grams per mole. And then silicon is 28.09. And then fluorine is all the way up here. Remember, we're going to use 19.00 for fluorine. All right, let's do those calculations. We'll calculate the molar mass for this compound, and then we will do it for water. So let's see. This is going to be 63.55 grams per mole, 28.09 grams per mole, and 19 times 6 is 114. And with this one right here, I only have 4 significant digits here, so I want to only put 4 significant digits in this answer. And we want to pay attention to our decimal places when we add these together, because remember, if we're paying attention to significant digits, I'm now only going to have 1 decimal place because this one only has 1. So let's go ahead and just add our numbers up. So I've got 63.55 plus 28.09 plus 114. And that's going to be 205.64 in my calculator, but remember I can only have one decimal place, so it's going to be 205.6 grams per mole. All right, so there's my molar mass for copper 2 hexafluorosilicate. And now I need the molar mass for water. I'm going to do that over here. I've got hydrogen and oxygen. There are 2 hydrogens and 1 oxygen. The molar mass for hydrogen is 1.01. The molar mass for oxygen is 16.00. So let's do that math. 2.02 plus 16.00, and I get 18.02. And for water, what I recommend is, because we're going to have to calculate this molar mass so many times this year, is if you just memorize the molar mass for water, that'll be easy. So you don't have to do this calculation every time. So water is 18.02 grams per mole. All right, now I have a molar mass for both compounds. I can divide by the molar masses to determine how many moles of each I have. And so I'm going to divide this by 205.6 grams per mole, and water 18.02 grams per mole. And now let's do those calculations. So I have 65.5 divided by 205.6. And that tells me that I have 0.3. And how many sig figs do I need? I need 3, because I have 3 here. This one had 4. It matches the one with the fewest. So 0.319 moles of CuSiF6. All right, and then for water, I have 34.5 divided by 18.02, and I end up with 1.91 moles of water. All right, so now what I want to do is I want to divide the moles of water by the moles of the compound. I'm either going to have 1 mole of water for every mole of the compound or more. So I want to always put water on top. Always remember to put water on top for this calculation. So I'm going to take 1.91 moles of H2O, and I'm going to divide that by the moles of copper 2 hexafluorosilicate. So 0.319 moles of CuSiF6. All right. So the reason we're doing this step is because we are trying to figure out how many moles of water there are for every mole of this copper compound. All right, so I'm going to do 1.91 divided by 0.319. And that tells me my calculator answer is 5.987. I'm going to round that to the nearest whole number, and that's going to tell me that I have 6 water molecules for every unit of copper 2 hexafluorosilicate. Now, you should, if you don't get exactly an exact whole number, you should have a number that is very, very close. You should not end up with something that you have to round so much. You shouldn't end up with like 6.5 or anything like that. So it should be very, very close to a whole number, close enough that you can just round it really, really easily. So that's this. We're not done with the answer yet, though, because I want you to know how to name these as well and write the formal formulas. And so we're going to write the formula first. So I have CuSiF6 dot 6 moles of H2O, or molecules of water, whatever scale you want to think of this on. And then to name this, we would say copper 2 hexafluorosilicate. And then since this is a 6, we would use this prefix over here, hexa hydrate. So this is really your final answer right here. That's how I want you to answer them in your class kick assignment. All right, so that is this one. Let's go ahead and do one more example. All right, for this next example, instead of being given the percent composition, we're actually given the mass data. So we might have to do a little calculation in the beginning to determine how much of our anhydrate and how much of our water we have. So let's go ahead and take a look at the problem. All right, a 4.175 gram sample of a hydrate of copper 2 sulfate, which is, the outline of this formula is right here. We're trying to calculate this, is heated until all the water is driven off. The resulting anhydrous compound weighs 3.120 grams. What is the formula of the hydrate? All right, so what we have to do here, it's telling us, we've taken this hydrate, we've put it over a flame, and we've heated it until all of the water has been evaporated out of that crystalline substance. The anhydrous compound is what's left after the water evaporates. So if we take a look at this formula, let me erase my underlines here. If we take a look at this formula up here, this part is our anhydrate. If we evaporate all the water, that is all that is left. So the resulting anhydrous compound weighs 3.120 grams. And we need to know an amount for the anhydrate and an amount for the water separately. Just like we did when we calculated the formula in the last example, we already had our anhydrate and our water separated there. But in a problem like this where we're given the mass data and it's telling us that we've evaporated water, you have to calculate how much water evaporated in this case. Sometimes it'll tell you the mass of the water that evaporated, and you're going to have to calculate the amount for the anhydrate. All right, so read these problems really carefully so that you know what you're looking for. So our goal here is to have an amount for copper sulfate and an amount for water. Always have to have an amount for each of those. All right, so it tells us that our resulting anhydrous compound weighs 3.120 grams because it's saying that's the anhydrous compound. That's copper sulfate here, copper 2 sulfate. So 3.120 grams of this compound. And then in order to figure out how much water was driven off, we have to take the mass of the hydrate, which is the copper 2 sulfate salt with water incorporated into its crystals, and we have to subtract the mass of the anhydrate. All right, so if we do that, 4.175 minus 3.120, that equals 1.055 grams of H2O. So this was the CuSO4. And this up here is our hydrate. Just so we know, we're really clear where all those numbers are coming from. All right, so here's my water, 1.055 grams of water. All right, now what I want to do, I have the mass for the anhydrate, I have the mass for the water, and remember, I'm trying to figure out the ratio of copper 2 sulfate to water molecules in this hydrate. And so my goal here needs to be to convert both of these to moles so that I can compare the quantities of those particles that I have. So we need to divide these by their molar masses to be able to convert from grams to moles. All right, and so we need to calculate the molar masses. And remember, if we're just remembering the molar mass for water, it's 18.02. So I'm going to put the molar mass for water here, grams per mole. It's easy just to memorize that because we're going to use it so much this year. And then let's calculate the molar mass for copper sulfate. So we've got copper, sulfur, and oxygen. 1 copper, 1 sulfur, and 4 oxygen. Oxygen is 16.00. And let's look up copper and sulfur on our periodic table. We used copper in the last example, so 63.55 for copper. Oops, and I meant to make those multiplication signs. All right, and then let's look up sulfur. Sulfur is 32.07. All right, remember we're using 2 decimal places for all these. So let's go ahead and do our calculations and add everything up. All right, so now I've got 63.55 plus 32.07 plus 64. And that means that my mass here is going to be 159.62. Oops. 62 grams per mole. All right, so that's the mass for copper sulfate. So I'm going to use that mass up here, 159.62 grams per mole. And then I'm going to perform that calculation. So I have 3.120 divided by 159.62. And that tells me I have 0.0, and let's see, I need 4 significant digits. So 1955 moles of copper sulfate. And then for water, I have 1.055 divided by 18.02. And that tells me I have 0.058. Again, I need 4 significant digits, 55 moles of H2O. And this is copper 2 sulfate. All right, so now I know exactly how many moles of each one I have. And remember, in this next step, I want to determine how many water molecules there are for every unit of copper sulfate. And so I'm going to put water on top, and I'm going to divide that by the moles of the copper sulfate. So 0.05855 moles of H2O divided by 0.01955 moles of copper sulfate. And if I put that in my calculator, 0.05855 divided by 0.01955, that tells me I have 3 water molecules for every molecule or unit of copper 2 sulfate. And so my formula, when I rewrite this formula, I'm just going to write CuSO4 dot 3H2O. So there's my formula, and now I need to name it. So I can use this up here, copper 2 sulfate. And then my prefix here is going to be tri-hydrate. All right, so this is my final answer. One thing that I do want to say is you want to be very careful with significant digits, especially when you get, all the way through, but especially at the end, you don't want to round too much, because sometimes if you round these numbers, it can actually change the number of water molecules you have. So don't round more than the problem tells you you should, according to your significant digits, so that you end up with the correct answer. All right, so I hope this video was helpful. If you have any questions, we can talk about it in class, and I will see you guys then. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.